Well, hello there and welcome to a webinar about data sharing principles. My name is Bente Liliaby. I'm going to be your host today, but I also have some stocks invested in data sharing from my time in the group of Earth observation. Now, this webinar is a co-hosted webinar by two Horizon 2020 projects. It's eShape and NextGeoSS. What is common for these two Horizon 2020 projects is that we are producing a lot of applications and services based on Earth observations. In eShape, there are 27 different pilots being developed covering a whole range of topics. In NextGeoSS, which is a European data hub and platform, we are now more than 14 different pilots covering, again, also the same range or a wide range of applications. So obviously, data sharing and data management principles are key to us, and we are super happy to have some very, very skilled experts with us today. And I will introduce you shortly to them. Here you see Sylvie and Bob. But before we really start, we do the regular thing that I do when I'm hosting a webinar. We do a weather report first. So, Sylvie, well, I can reveal you will be introducing yourself later, but I can reveal that you are working for Météo-France. So, can you tell us what the weather is like where you are and where you are right now?
I am now in Toulouse, in southwest of France. The sky is blue. We had fog this morning, but now it's weather is very good, and we have 8 degrees Celsius.
Ah, sounds wonderful. How about you, Bob? And you are on the East Coast.
Yes, I'm in New York, just north of New York City. And here it is 0 degrees Celsius and clear. We had some snow a few days ago, but now we have somewhat better weather at the moment.
Oh, sounds nice. Here where I am in Norway, and just a little bit northwest of Oslo, and we have a rather warm for the time. Actually, we had a lot of snow the last few days and -10 or something, but now it's actually plus degrees, but lovely, slightly overcast weather. So it's a nice weather here as well. And so I would love for you also to give us some weather reports from where you are. You as attendees have the possibility to write in the chat. So there's a chat box, and that's where you can tell us where you're from and what's the weather like. And I will come back to that chat box later. Now, for this webinar, we will cover data sharing principles and data management principles. We will get some examples, and we have some Q&A at the end. And for the order of the webinar will be that we start with an introduction to the GEOSS data sharing and data management principles, and Bob will give that presentation. And then we have some very remarkable examples from Météo-France, and Sylvie will tell us about those. It involves in situ data. Now, many of you have heard about the FAIR principles. That's also data management principles. And Bob will actually show you some of the differences and the similarities between these two sets of data management principles. So that's the program for today. I will allow some, or not only allow, I will encourage some questions after each of the presentation, but the main Q&A will be after the last presentation by Bob. So with that, I think we are ready to start. We will have about an hour or so for this webinar, so you can plan your time. And I will let the experts, Bob and Sylvie, introduce themselves when they are starting their presentation. So you will learn more about what their background and so on are also. So with that, I think we're ready. Bob, I will give you the floor first, so you can introduce yourself and what you do. Are excited?
Great, thanks, Bente, and I sure wish were in the French Riviera where it looks really nice. But anyway, I'm Bob Chen. I am here in New York at Columbia University. I run a center called CEASIN, the Center for International Earth Science Information Network. I also run a NASA data center called the Socioeconomic Data and Application Center. Just as background, I've been involved with data sharing in GEOSS since I think it was about 2006, a year or so after the GEO was formed, and at the time was involved with CODATA, which helped co-chair the original data sharing working group or task force. So let me go ahead and turn off my camera and start the sharing.
Yes, and we will turn off our cameras, all of us. We will not disappear, but we will turn off our cameras. So, can you, yes, it's visible, but Sylvie, can you also turn off your camera again?
Yes.
Yes. So, yes, I think we are ready, Bob. Go ahead.
Okay, great. Well, so what I'm going to try and do, as Bente said, is give you a quick overview of the data sharing and data management principles. I want to point out that this presentation was done with Bob Downs, who works at CEASIN and CDAC. He's a senior digital archivist, also a member of the Core Trust Seal board. And he had been involved with the GEOSS Evolve effort, which had focused on the data management principles. So with that intro, let me dive in. Won't go into the longer history of the data sharing principles, which, as I mentioned, started with the first GEO implementation plan in 2005. But through a lot of efforts over the years by the data sharing working group and others, GEO updated the data sharing principles in 2015 in Mexico City, in which it recognized that although the original data sharing principles were ahead of their time back in 2005, it was important for GEO to stay ahead of the curve and recognize that the world has changed. Many international organizations and governments recognize the value of things like open government data, and that GEO should update its principles to really recognize first, of course, the benefits arising from open sharing of data, information, knowledge, products, and services, but also that data should be open by default. That is, the assumption would be that data entering into to be part of GEOSS, a global Earth observing system of systems, ought to be assumed to be open unless the contributor specified restrictions or charges or other conditions. So that's the first principle. The second principle, of course, being a voluntary intergovernmental organization, GEO is not like a treaty. It's not like a UN organization. We can't escape the idea that international instruments, national policies, and legislations do supersede things like open sharing of data where it's necessary. And of course, as scientists, we recognize there are certain areas in which data sharing, fully open data sharing, isn't always possible because of things like privacy and security concerns. So Principle 2 continues that, but it also emphasizes the need for minimizing those restrictions and limiting the cost of reproduction and distribution. And finally, the third principle, which carried over from the first set, was that minimum time delay was important. That getting data out quickly, not necessarily reserving time for a scientific publication, for example, was important. So the other half of this is GEO's effort to recognize and provide principles and guidelines related to data management. These evolved really in the last 5-6 years. And I think the group that developed this did a very nice job of clarifying, grouping, and actually labeling the different data management principles. I'll go through them very quickly in a minute. But I think it's important to recognize that these have been accepted by GEO members and participating organizations when they join GEO. But of course, GEO's not, as I said, is voluntary. It can't impose policies or procedures. It can only make recommendations, develop guidelines, and encourage compliance to the extent that it makes sense. So there is a brand new joint data sharing, data management working group that was formed at the Canberra Plenary and Ministerial a couple of weeks ago. It's still being reformed, but many of the earlier participants are going to continue. But as I'll say at the end, we're looking for new participants. So very quickly, discoverability obviously is a key issue, and metadata is essential to that. I don't think for this group I have to go into it in much detail, but certainly one issue is if there are data rights issues, licenses, that should be indicated in the discovery metadata. Online access, kind of a no-brainer. But encouraging not just download, but increased use of services, using open standards. I'll note, of course, that OGC is one of the co-organizers of this and has been very supportive of these types of approaches. Usability includes 3 principles. And again, I won't go in great detail, but to make data usable, obviously, they have to be reasonably and structured. There has to be good documentation. We really need to ensure traceability of data and have clear and transparent quality control. Again, I think once stated, these are pretty obvious, but getting these and starting to articulate how best to achieve these principles is part of the challenge. Preservation has 2 principles that, of course, one wants to ensure that data isn't lost and that procedures are there to support that, and that also the important data and metadata has to be verified and validated to make sure that they're actually accurate and authentic and reliable. And finally, somewhat separate from preservation is this idea of curation, and that data isn't necessarily just a static thing that you stick on the shelf, that it requires review, that certainly from the scientific community's viewpoint, reprocessing is key. And then, of course, if you have different versions and good version control and traceability, you really need persistent identifiers. So those are the 10 principles. As you can see, for somewhat historical reasons, the data sharing principles and the data management principles were developed in parallel within GEO, and there is, definitely overlap in what they discuss. I would say the principles to get more at some of the policy approaches of the GEO community, and the DMP does focus more on the mechanics or the implementation of good data stewardship. So this is just a little bit of an illustration of the correspondence. I won't go into it in too much detail, but if you have questions, we can answer that. Actually, Bob Downs, I think, is on the call, so may also be able to help with responding to questions. So let me just conclude. The Data Sharing and Data Management Working Group has a new set of terms of reference that were approved by the program board and by plenary by virtue of being in the new work plan. I'm not going to go into gory detail, but it does cover the general issues of what's happening internationally on open data. There is interest in helping the GEO community to document the value of the data being open. There's been activities related to how to translate the work at the international level to countries that are still trying to encourage open access within their countries, and look at interoperability and best practices and issues like metrics. So it's a large agenda. The group is still trying to formulate priorities. In fact, we have a important telecon next week, which others are welcome to join. It includes formalizing who the co-chairs will be, and we certainly welcome new members. There were at least 25 people at the side event we held in Canberra, and we're hoping that there'll be a lot of interest in carrying these forward. There is a GEO site about OpenEO data, a set of pages on the GEO website, which is there, and you'll find links to some of the previous documents that the Data Sharing and Data Management Group has prepared in the past. And I think that's it from now, but certainly happy to answer any quick questions about this.
Yeah, thank you very much, Bob. Certainly a very important role of GEO that you have described in more practical terms here. I hear an echo, and I think can you unshare also your screen, Bob? And turn on your camera. That goes for you too, Sylvie. If you are there, I saw there was something happening while you were speaking. Yes, okay, thank you. Okay, so thank you, Bob. It's immensely amount of work that has gone into this to this end result. And some of us has been part of this. And actually, I forgot to mention, but you and I, Bob, we have known each other since the very beginning there, being a part of the group on Earth observation community. And concerning I just wanted to also highlight, you partly covered it, Bob, but the difference between data policy and these principles, and then the management principles. So sharing principles and management principles. Can you reveal some of the discussions that has been around this policy versus more implementation of the policy?
Yeah, I think it was. It was something that came out of the origins of GEO back in 2005 when, for example, the principles were being negotiated. Yeah, it's this idea, since GEO is voluntary, the member governments don't feel that it can set policies where the implication of the term policy is that members are obligated to conform with the policies. And so the governments were fine with principles that are, of course, aspirational, and all the members can aspire to adhere to the principles. And oddly, they're fine with guidelines and procedures that are established because, again, a country can follow the guidelines or follow procedures or not, and contribute to GEO and GEOSS what they want. But we were very explicitly told, don't talk about policy because governments will read that as a prescription coming from a group that, doesn't have the status of the UN or a treaty where governments had actually made an agreement to abide by something. And so that's the distinction that we've had to be careful to make for the last 15 years.
Yes, yes. So it's I wanted to highlight it because for many, policy can be within an organization as well. But in this context, we are talking about policy as a governmental policy, and as you said, more legally binding. So that's why I wanted to make sure that people understand the difference and the reason why we are talking the way we are talking about this principles in GEO. So Manuel, he's asking you a question, Bob. How do you achieve version control? Do earlier versions of data sets remain available within GEOSS?
Well, I think the availability is up to the providers. I think what the principles argue for is that all versions have a persistent identifier, so that you can see that there's a change. You can trace back, at least to the metadata or landing page, the previous versions that might have been used, say, in a paper. But the availability is kind of another issue, because obviously that impinges on resources and other issues. I mean, I certainly think most of the data managers would want to keep earlier versions in some form, even if the level of service is limited.
Yes, thank you for that. And I also want to emphasize this, Marie-Françoise Vadreau from ODC, as you mentioned, Bob. So Marie-Françoise is working not only in OGC and not only in XGEOSS, but also in eShape. So we are happy to have Marie-Françoise with us here also today. We can bring her in the room. If you have questions directly to Marie-Françoise, we will be able to bring her in the room so she can answer directly. But for now, in order for us to move on, I think it would be great now to hear an example of the value of actually adhering to these principles. And Sylvie, I think you have a great example to show for us.
Yes, I try to.
Yeah, but before you do the screen share, can you introduce yourself so people know a little bit more about you?
Okay, so I work at Météo-France, the French National Meteorological Service in Toulouse. I am a climatologist. I always was a climatologist, and I have been in charge of climate data rescue for in situ station since 2003. I am climate data rescue is a very long-term process. And that's why we can recover data a long time. I am associated expert of the WMO expert team on data rescue and management. And Météo-France has been involved in several international and national data rescue projects. We are now involved in the Copernicus CS3 ACE data rescue project.
Okay, nice.
I
So
think
we have a real
it's enough.
expert. Yes, yeah, no, well, I'm sure there's more, but but this is really you are really a user of the data and working with the data as well. So let's hear it, Sylvie. I will turn off my
Yes.
camera and then
Yes, I turn. Okay, I share. So,
yes,
yes.
and then turn off your camera.
Ah. Turn. Yes.
So please, yeah. So while
Yes, I
Sylvie,
have to do. Yes. Yeah.
yeah.
Mm-mm.
So thank you for the questions, by the way, and do please ask questions again.
Is that okay now?
Yes. Go ahead,
Yes.
Sylvie. Yes.
Yes. So I at first I will explain briefly explain what is a climate data rescue for metallurgists. Climate data rescue is an ongoing process of archiving, searching, and locating climate records on microfiche or paper media. So, for example, Météo-France has climate archives, and we have around 8 kilometers, linear kilometers of paper archives. The climate data rescue, the second action is imaging original documents, storaging of image files, and on for Météo-France on the Météo-France storage server. The third task is digitizing data values, methodological parameters, and of course, quality controlling digitized data. The last task is integrating digitized data and metadata into the French National Climatological Database, BDCLIM. So I will insist when I say data, it's always data and metadata. Data rescue, climate data rescue involves rescuing both the data and metadata. So I would like to show, in order to explain what is climate data rescue, to show the material of climate data rescue, we have original sources of methodological formulas containing methodological observations. So in the right, you can see original source, rainfall observations. It's a monthly formula, and I wanted to show where are the data on the sheet and where we have the metadata in the sheet. We have on this sheet several parameters observed: visibility, wind direction, wind strength, rain and snow depth, for example. And we have a lot of metadata, but in different forms. We have the producer, we have the title of the document, we have the date of the document, we have the name of the station. It's written that the observations are made at 7 in the morning. We have the name of the observer, Lucien Chianelli, Water and Forest Guard, so we can know the network of the data. And we have the document reference. It's ONM 59 bis. So it's we know that the producer is the Office National Météorologique, so the National Meteorological Service at that time. So we review all the documents generally to keep and to search all the metadata and data. The second page of the document is instruction for observers, and in this sheet we have a lot of metadata, very important metadata For example, we know that observations are made every morning at 7 o'clock, but in winter time, not local time, not UTC times, winter times. We know that rain is measured at 7 o'clock, but the total is from the previous day, and this value should be attributed to the previous day in the database. This kind of metadata is very important, and a lot of former colleagues did some mistakes when they put the data in the database, because the value is in the line for the day D, and the value is guilty for the day for the previous day. So we know that the wind direction is written in 3 letters. It's old wind rows in 16 direction. We have the wind strength scale from 0 to 6. It is not Beaufort scale. It is not wind speed. It's a special scale. And at the end, we know that monthly precipitation is calculated without the value of the first day, and the value of the first line should be attributed to the last day of the previous month. So just to show, to illustrate what material we use to recover climate data rescue in situ station. Now I will illustrate how we are organized for this action of early data rescue, and how the data management principle are in the heart of our work. So I will show you all the example of the principle, data management principle. First one, metadata for discovery, so discovery element. For their data rescue projects are closely and labor intensive. It takes a lot of time to locate data, locate records, and to find metadata. So duplication of work should be avoided. The important first step is to check whether the climate records of interest have already been inventoried. So catalogs are very important, and CS3S was very motivated to create the global registry to catalog all the data recovered under several international projects. So now, the most comprehensive source of such information is the Copernicus CS3S Data Rescue Registry. So you can have catalogs from upper air observation metadata inventory, for example. Météo-France participated to a project on upper air observation, and all the data are inventoried and in catalogs. DMP2 online access. So when we search all data, earlier data, we search everywhere, and it's very useful for us to have accessible data via online services. It facilitates our work. We can find images in publications containing climate data. For example, the French National Library has an online service, and images of publications can be directly downloaded. We have a lot of old publications with climate data, and NOAA Library, for example, gives give access to image publication, and publication can be directly downloaded. Very useful for Africa countries, for example. We can too find some image archives, image original sources online. For example, we participated to image the meteorological observations of the Royal Society of Medicine. So with the access to this very old data from the 18th century, we could recover some data from this period. So thanks to this access. For data, there are a lot of databases, and for example, French climate database, BDClim, French climate data are stored in the BDClim and accessible via online services. This data is accessible via online services for download with a visualization. About international databases, for our work, these databases are not so useful because the national database is more precise, and in international databases there were a lot of amalgamation of broad range of underlying sources. The DMP data encoding. The target user community here is the climatologists of Météo-France. We have a national French climate database, BDClim. We use the PostgreSQL management system. We have different tables for data and metadata management. This is due to the history of the organization of the climatology in the past. We had special metadata formulas, information about the station, information about the station, and this formula was filled when creating the station and during the visits, site visits. So every year, data formula or climate formula, meteorological observation was filled every day or every month and sent to the national office every month. So the documents were not stored at the same place in the same location. We have different tables for hourly, daily, or monthly data. This choice is aligned with organizational needs and observing methods and user needs. It's very often in National Meteorological Office, this kind of organizations of data, and daily and monthly data are consistent with hourly data. And in the National French Climate Database, we of course have all the international standardized parameters. For data rescue, we don't recover all the data, too many data, and we recover the essential climate variables, and we recover the closest data to the original observations. That's it means that we recover daily temperature and precipitation, and we recover sub-daily surface pressure, sub-daily temperature, sub-daily wind speed and wind direction. We recover upper air temperature, wind speed and direction, and snow depths. I'm waiting because I know that it takes time to have the slide. About data documentation, early observation used a broad range of instrumentation, emerging measurement system, and disparate measurement scales. When I say early observation, it means data from the 18th centuries. Retrieving the metadata is a very long and expensive process, which requires a lot of expertise. We do it because this data is super important to our work. We look for metadata everywhere, in every archive we have, on the web too. This is why I I am happy to have this opportunity to advocate for good quality and comprehensive metadata. People in 1990 century might not know how important their data will be 100 years later. Now we know. So if I will explain what we do to recover metadata. For example, methodological formulas containing data of early observation are poor in metadata. So we review the formula, and the review of all the formula permits to know few elements, but very important: the name of the station, the altitude of the station, observed variables, of course, unit of variables, altitude of the barometer, and the network of the station. For example, hospital, school, lighthouse, airport, and army. And with the knowledge of the history of the methodological observation, with the search in different archives, in the database, on the web, we are capable to identify the station and its location. It can be very long to identify the station, because sometimes there are some mistakes in databases, there are some mistakes in the documents, so it's a detective work. So it's very important to identify the station, and it's not so easy because we have a very rich heritage and we have several stations in the same city for previously. After searching in the metadata sheets on paper form, on catalog of instruments and publication, we can finally give a few but very important elements to be integrated in the climate database. So we try to put name of the city, location, history of the instrument, history of the altitude of the station, history of the altitude of the barometer, if there is a barometer, observed variables and units. It's basic, but we are trying to give this kind of metadata for all the early data recovered. So I wanted to add that for this element data documentation, it's recommended to describe in peer-reviewed publications reference in metadata records. So I have a very good example in the framework of the European project ERA-CLIM. There is an article describing the upper recovered, and data are cataloged and can be downloaded, free downloaded on the web. Data traceability. We are trying to keep all the steps of the data rescue chain action for each series, long-term series that we recover. We follow all the different tasks, and since 2007, all the steps of the data rescue chain has been described in a file. Action identifier, original sources, images, storage locations, specifications for data keying, very important for digitized data, name of keying operator, unit conversion calculation. Raw digitized data are also kept, and because operator case as ECs, so it is not the original sources, but it's not so far from the original sources. Now we are trying to do best, and a new table in the database is being developed in order to keep some metadata about data rescue actions, in the climate database for direct access and direct easy access. Identification of action, station identifier, parameters, period, location of all digitized data. So a lot of metadata about the just action of rescue. And we have a special table in the database, data risk insert, to trace all the actions. So because the provenance of metadata is very important, super important to us, we want to return, to be able to return to the sources when we do some controls, check quality, and when we have errors, we want to know where we want to know the provenance of the errors. Data quality control. So quality control is a continuous background task in the climate department. For early data, data rescue actions, access to original sources is the occasion to check data already in the database. So we know that we have mistakes in the database, and when we have access to the original sources, we check the data already in the database. First checks and basis checks are station, date, and parameters. Sometimes there were previously some errors of identification of the station, errors of the date of the station, sometimes 1 day error, and sometimes error with parameters. For example, the pressure at the level stations and the pressure at the sea level. Numerous mistakes were made, and so we have to, for example, between lighthouses and semaphore, the location of these two buildings are very near, and so sometimes they did mistake about lighthouses and semaphore. We do other quality control on early observations. Digitized data, after digitizing, are checked before integration in the database by different automatic quality controls as close as possible to the controls used by controls used today and every day. Each early data has a quality control in the database. Data origin can be provided for early observation rescued since 2007. Before, we didn't have the metadata about early data in the database. We have a special table too to describe specificities found on a series. For example, we have at the beginning of the 20th century a lot of non-standard shelters for temperature measurement, and it's very important to know if there is a shelter for the measurement of temperature.
Sylvie?
Yes. Yes.
I see we are on 6, and we have 3 more. I'm looking at the time. I hope Bob is able to stay on. This is really interesting.
Yes, I thought it's too long because I have. Perhaps I can just go to the DMP9, very important for climate change.
Oh, you can do all of them, but just not so thorough. Yeah.
I changed. So I am in DMP9 about data review and reprocessing. Each project is an opportunity to review the data and its metadata with a new view that helps identifying the errors and heterogeneities. So in order to study the climate change, it's very important to study to study the long series, and because the long-term instrumental climate records have inhomogeneities, artificial shift due to change in the measurement conditions. So for temperature, for example, the change of shelter is a source of break in a series. So all the methodological services have an important activity of homogenization of long series that aims at reviewing long series of data and identifying the disruptions. So for this kind of work, metadata are very useful and very important to analyze which can be the source reason for this disruption and to determine accurately the break dates. So we homogenize the temporal series of temperature and rainfall, and we store this monthly homogenized series of measurement into a new data set in a new table in our database. We always keep the original data. So these homogenized series are the reference series for climate change detection and attribution studies and for past climate evolution diagnosis. DMP10, persistent and resolvable identifier. For us, key and the identifier for a station is for the series is at first a station identifier, unique and persistent, key element for the database, common element for all the BD-CLIM tables. It's a national identifier built with the National Statistics Institute number of the place of the municipality. We build the station identifier with the number of the city and the number of the station in the municipality. WMO identifier is not used because very few stations have a WMO identifier, just professional stations. And WMO identifier has been used for several measures. The same identifier, WMO identifier has been used for several measurement sites. So we don't use WMO identifier for rescue. So data are specified by the station identifier, the date, the parameter, and the temporal frequency. So it's the last DMP. So I finished.
Thank you so much. I'm sorry to interrupted you there. I was just looking at the time.
Yes.
But can we share your presentation, your slides? Can people get this?
Yes.
Yes, great. So we can share, because you went through each and every one of the data sharing principles there and gave us some very concrete examples in the field of climate change and climatology. So before we go on, I would like to ask Bob, do you have time to stay on beyond the hour for the Q&A, or how is your time?
Yeah, no, I'm available.
Yes. And you too, Sylvie? You are able to stay on a little longer? Terrific. Then I will just to make sure that we get your presentation also, I will take the Q&A for Sylvie at the Q&A. And then we just go straight on with you, Bob, to compare these principles that Sylvie showed in practice with the FAIR principles that many of us have heard about.
Okay, great. Is my presentation visible?
It is, and we are turning off our cameras, and you are good to go.
Great. Well, I'll try to make this brief. This is actually not intended to be an in-depth comparison, but really just to highlight what some of the issues are in thinking about the GEOSS data sharing and data management principles and the FAIR principles. So I'm assuming that most people have heard about FAIR. It came out a few years ago. and has a very nice acronym: findable, accessible, interoperable, and reusable. You can see how they're defined according to the Go FAIR organization, which is online and I think well known certainly in Europe and other parts of the world. Well, what I will say is, FAIR is aimed broadly at the scientific community, data and services. So quite a broad range of data in which, for example, there may be sensitive personal data, there may be early experimental data, both public and private funded research, both long tail, small to very large projects, and diverse disciplines. And I mean, I think it goes without saying that we all know that many disciplines vary, shall we say, in the level of accessibility and consistency in how they manage their data. So the general idea that bringing all sciences up to a consistent set of principles that does work for all the different disciplines, given reasonable constraints on access, makes sense. And FAIR, I think, is helping in that process. What I think is important to remember is that the Earth observation community through GEO is working with arguably a more limited variety of data, and has set a higher standard in some cases for both data access and management. As you dig into FAIR, again, there's a number of specific principles with the labels F1 through 4 and so forth. You see these here, and there's clearly a lot of overlap with the data management principles, but they're organized somewhat differently. So in the data sharing working group now, the joint data sharing data management principles working group, we're started what we're calling a crosswalk. It came out of some of the discussions at the Geo Data Technology Workshop earlier this year. But what I would argue is that the FAIR doesn't really explicitly address the open access policies. It indirectly comments on them when you read the details as interpreted partly by the Go FAIR project. But FAIR does, it gets, as I said, the mechanics of saying one should have a license, doesn't say open license, one should have a persistent identifier and so forth. So, the crosswalk is actually fairly complicated and may vary between disciplines. For the Earth observation community, I think the data sharing and data management principles in some sense cover even a broader set of data stewardship issues like curation and preservation that I don't quite think FAIR gets at. So this is just something that Bob Downs and I have created. We've done a little more digging into the comparisons, but this just kind of gives a quick overview of some of the different issues addressed by the DSPs and DMPs versus FAIR. So let me, I realize I was really brief. Let me just conclude by kind of re-emphasizing where I think the open data sharing part that GEO has adopted is really valuable. I mean, as we just saw from the climate issues, climate is now recognized as a crisis. We need rapid scientific progress. Open data sharing facilitates that type of openness, replicability, speed, and really the trust and cooperation that people are sharing their data, not trying to hide or hoard or bias things. And that's really critical these days. And we don't have time to, have people duplicating their efforts. We need to build on data, put different data types together, give all stakeholders access to data so that they don't feel left behind or feel like they can't trust what is being done because the models don't incorporate all reasonable sources of data and so forth. So I just think this is a key topic. It's, as Bente said, been one of the major accomplishments of the GEO community in the last 15 years, and I think keeping a focus on, certainly for the Earth observation community, on open access, which I would rate as being above the standard set by FAIR, is really critical. But let me stop there since we're out of time.
Thank you, Bob. Thank you so much for that. We can come back to code again. And yes, it's very interesting to compare the FAIR principles with the GEOSS principles. And not the least, I have to admit, I'm really proud on behalf of the GEO community what we have achieved with respect to the data management principles. I think in short, Bob, you could say that you said very carefully, very diplomatically, that FAIR is not covering, I would say the data life cycle. So in GEO, we also address the last part of the life of data, as Sylvie has shown us so clearly that these data is really, really important for reuse and to keep them alive as long as possible. So I want to open questions. I see while you are writing questions to both Sylvie and Bob, I'm going to share the comments that Marie-Françoise has written, in case you haven't noticed. She points out that Sylvie, you are working relentlessly, I think, to search to find more data. That is right. You have a rich heritage, haven't you? I guess you have long time series covering basically the entire world.
Yes, we have data, long series from French overseas territories. So New Caledonia, French Polynesia, Réunion Island. And so we are working on this kind of for these territories. And fortunately, archives are in mainland France and in the national archives. So we could recover the data, image the data, and digitize the data. So the data came from hospitals, military hospitals.
Oh, really? Interesting.
Yes. The Marines went to the colony, and the first step was to do some methodological observation because of the health, because some illness and so.
Yeah. So very interesting. So you have Earth observation data from hospital. We have health in GEO as one of the societal benefit areas. But yes, Marie-Françoise is pointing out, as you may have understood also, that the point with having you describing so detailed, Sylvie, each of the data management principles is to show that every one of them is actually important for us to be able to use it, right?
it's a very long chain. We have a different, very different task, and we have to follow all the tasks. And so we want to trace all the steps, because now we can see that we have some mistakes, old mistakes, and it's very difficult now to know why. And so that's why now we are very motivated to trace all the tasks. So
That's
it
great.
takes a lot of, oh yes, it takes a lot of time to know, analyze the mistakes, the errors, and to understand why. And because people did some correction, modifications, and so now we don't understand the different. It's very difficult to analyze. That's why we are very strict now.
I can imagine. But the thing is, Sylvie, that I learned from Interos, another Horizon 2020 project, who is currently, they are collecting data in the Arctic, so very remote and demanding areas. And what you described that you are doing with historical data to collect the metadata and really record it and digitize it and so on, it's still a problem for today's data, because not everything is a satellite data, right? Where everything is more automatically done. So I think my point is that your example from historical data should also be inspiring for those who are struggling with making current day data also is as accessible as you are working on with the historical data. So indeed, it is demanding what you are. And a question is that for those who are funding, so this is not done for free. Somebody actually has to have resources to do it. So you are employed by Météo-France. So Météo-France is financing your efforts. But in projects, like for a research project, which has a time limit, they struggle to find or to explain the need of resources for the things that you are doing. Is science on one hand, and then analyzing the data afterwards. But there's a lot going on in between, right, Bob? Do you recognize this from your world?
Oh, sure. There are clearly a lot of different trade-offs in terms of where to invest resources for, gathering new data, managing and preserving the data to these increasingly rigorous standards, and doing analysis and applications. And, I think it is part of that larger life cycle where, one of the issues with thinking about the value of data sharing is to actually try to look at where the resources are needed, how that's obviously changing because of technology or not, and where to balance the data gaps that need to be filled against new types of sensors and so forth. So those trade-offs are always going on. What we found is since the center I run is basically a soft money center, is that we've been looking to different sources of funding outside traditional research funding, which is of course limited, to support some of the necessary work.
Yes. So it's important. That's why I really, really appreciate you, Sylvie, taking the time to explain so detailed to us. And now it's on record. So we can use this as a good example in Geo as well, right, Bob? I think this will be useful for the Geo community. Marie-Françoise? Yeah.
Well, I was just going to say that it's great because I actually have a master's in climatology and did a lot of early analysis of ship temperature records, which of course are also equally messy and hard to recover from historical sources and things. So that's definitely a difficult challenge to pull those kinds of data and make them available and useful for current research applications.
Absolutely. So, Marie-Françoise, raise your hand if you want to come into the room and make some comments. Meanwhile, while you're thinking about that, I can share what you have written. So, Marie-Françoise is very grateful, Bob, for you to remind us about standards that are there to support the work, which is comprehensive. And there's a suite of standards, different standards to cover all the needs. I think that was a good point that you made. I agree with you, Marie-Françoise. And what else? Marie-Françoise said that some people invest a huge work in creating data and do not know which metadata to document and do not finish the last mile to really bring their full value of their data. Yes. And again, this is both a resource question and also a knowledge, resource in terms of time and money, but also about knowledge. I saw that Christian Langer from GeoBon, he's working on GeoBon, and I think he was here in the room. I don't see if he's still on. But when it comes to metadata for biodiversity, it's a scientific discussion that needs to be done before you can sort of agree on a set of metadata that can be standardized. Have you, Bob? Has this been an issue that you have discussed in the working group in Geo?
Well, in the I've more been involved with the data sharing. I think the data principles group is data management principles group is pretty aware of the different standards. I don't know to what extent GEO has really considered whether formal adoption of standards is necessary. There are certainly other bodies out there that we're all many of us are part of that not only develop standards but focus on implementation. So it's I'm not totally clear whether it makes sense to put effort into wider adoption or agreement on standards. Certainly for the very the core infrastructure, there have to be some standards that are implemented, and that's probably been discussed in those geo tasks.
Yes, and I think it's a community effort that is necessary. So I will immediately jump to a question from Lionel. Thank you, Lionel, for commenting or asking. As I know, there is no one size fits all. ISO 19139 is a kind of a Swiss knife covering a lot of potential needs for metadata documentation. I'm not familiar with this ISO. Anybody here? Sylvie or Bob, do you know this ISO standard?
No, we have the WMO standard, so we go the standard. So.
No, I think you're right, Lionel, that there is no one size fits all. I think what we, I guess, concluded more or less is that each of the communities. So for biodiversity, the biodiversity communities is the right set of expertise or group of expertise that needs to develop that. Oh, hi, Christian. Oh, you're still there. Lovely. And then you have, and then you mentioned, Bob, that you need a core, the core infrastructure also needs to be based on standards. I know Marie-Françoise will be very happy to hear all this because standards is at the core. Marie-Françoise says the communities create profiles. Yes. But GEOSS, I mean, the infrastructure of Geo is the goal is to make the data interoperable, right? So standards is one of the tools to make it interoperable. The data management principles and the data sharing principles both are one of the tools, or two of the tools that we use to make data interoperable. I think that's the context of this. I don't know, Bob, do we the interoperability issue is high up in the consciousness of the group, I assume.
Oh yeah, I mean one of the areas that the data sharing people have worked in a lot is legal interoperability, and the use of what's essentially a de facto standard, which is the Creative Commons licensing. We looked at a number of other approaches to open licensing, but certainly Creative Commons was far ahead of anyone else in terms of having machine-readable licenses that were validated in basically every national jurisdiction around the world. So that in particular in that area is a standard that was recommended in some of the various both GEO and Research Data Alliance activities. The all the other data management principles each of them have their own set of standards. One that I know Bob Downs is working on is a new set of trust principles which relate to the stewardship. Those are still in development, but when we think, we not only have to think about the data being persistent in the long run, we have to think about the institutions that hold the data being there in the long run, because if they don't survive, then the data gets lost. And so there's a whole parallel effort of thinking about long-term persistence and stewardship of trusted digital repositories.
Absolutely. A good point. Thank you, Christian, he is sharing with us the latest essential biodiversity variable metadata development. Thank you for that, Christian. So there you can see some examples of a metadata that is necessary for sharing this data. And Marie-Françoise is giving us the number of the ISO for WMO that Sylvie is referring to. It's ISO 19115, y'all. So we are 1 hour and 17 minutes over the hour. Before we leave, I would like to ask you, I did a couple of polls. I saw that about half of you had heard about data management principles. So thank you for answering that. I will check the response to, I asked also, have you implemented one or more of the data management principles? And 70% of those who answered actually have done that. Now, we didn't have time to go very deep into all of these, so many of these topics, but it's a start. But if you can write to us in the chat what you would like to hear more about, we are planning to dive deeper into some of the topics here. We can cover more of the comparison between the geo data sharing and data management principle versus FAIR. If you want to learn more about that, we can go into individual principles if you like. We can go, I'm sure, Sylvie, that you have some more examples that you can share with us in climatology. So it would be wonderful if you could write in the chat right now if something springs to your mind immediately. And if not, please write it to us in, you could write a message in Twitter, NextGeos, @NextGeos, or you can go since you are here as attendee, you benefit from getting the replay rather immediately. Actually, a few hours after this end, you will have the recording in your inbox. Now, we will also post this recording on the YouTube channel of NextGeos, and that's where you can suggest more topics for future webinars. We organize a whole lot of webinars. I will be happy to organize more of these as a host. As you know, I'm I'm here all the time. So, and I'm sure you, Bob, we can ask you again, the Bob and the Bob from Colombia. I assume you will be willing to dive deeper, right? I'll put you on the spot here.
Sure, and you know, there is a broader group of people involved with the data sharing and data management principles working group who I think would also be interested in participating.
Yes, and we can bring more of the. I guess you have the group that you are in represent different types of background also with respect to this data sharing principles and management, so we can cover different angles to the same subject. Yes, and I think I see somebody raise their hand, and that's Marie-Françoise. Sorry, I didn't see it earlier. We will invite Marie-Françoise in the room. I just sent it to her. So let's see. She has something more on her. We say in Norwegian, we say on her heart. I don't think that's English, but you know, probably understand what I mean. So you said, Bob, you are going to talk more about these topics at the American Geophysical Union.
Yes, I'm in a session about FAIR principles on Tuesday in San Francisco.
So if you are going to San Francisco, you can listen and learn more from Bob there. And the next meeting, you said, I think you had that on one of your slides, that on the same week, right? On Friday, the 18th?
No, Wednesday.
Wednesday. Oh, okay.
Not till the week,
the week after. Yeah.
aging.
Right. So let's see. Marie-Françoise is not coming in here. Takes a while. Looks like. Anywhere else, Sylvie, is there anywhere else you would like direct people to go if they want to learn more about what you are doing?
More, it's difficult. So,
you mentioned a project. So some of the
yes.
data that you are analyzing, the results from that, is some of the data that you have retrieved, historical data, is actually being given publicly, open and public to people, right?
It's a good question. So we are Météo-France National Meteorological Service. So we have the national data policy. It's the answer is no travel. Some data are open, free opened, but climate data, so that I talk about, are not free. There is a royalty, but it's free for researchers and historians. If we have researchers demanding climate data, we provide them free. So, but it's when we recover data in some projects, it's free. It's all the data are given to the project and to a database, and Météo-France regularly provides selected long series to international databases. So it's not trivial, the answer. You understand? It's a mix of open, not open. So
right. Well, they have to inquire then. Jean-Dominique, he wants to know deep about tools to manage climatology data. Thank you, Jean-Dominique, for saying that. We will follow up. I'm sure, Sylvie, we have a follow-up here, I think.
yes, it's a very large question. So because there are a lot of elements for data management. So we have a system, a PostgreSQL system, and we have a special tool for quality control. And every day, when data arrives, we have a lot of quality controls. and we have experts supervising the results of the quality controls every day. And we have some automatic chain of to get data. So it depends on the domain of the management. So it's if it can.
You're reading.
You never receive climatic data. Yes, that's the problem. That's I said it's normally if there is a demand, we have to provide data, free or not free, but it's the job of Météo-France to provide data. So we have customers and we have a special service to provide climate data. So
Yes. So this is why we have Geo to help.
yes, that's true. So it's the so I receive every week demand on early data from historians and researcher, PhD, and so we try to answer. So I don't know what he did.
No. So Jan Christophe, you can try again, I'm sure. And then see, now that you know Sylvie, you might have somebody to address if you have problems.
So, and Marie-Françoise, yes, Marie-Françoise answered, that's true. There is a public web service at Météo-France, and a lot of data are online. So, and we can find the catalog of all the French stations. So the metadata are cataloged and the stations are cataloged. So, so it's, I think it's a first step.
Yes,
To go
absolutely.
to the website.
Yes. Listen, this has been awesome. Thank you so much, Bob and Sylvie, for excellent presentations. Very inspiring and very informative, and useful for the entire Earth observation community, that's for sure, and beyond. So thank you so much. Thank you also to the attendees for joining us here today. Thank you for your engagement, for your weather reports and suggestions. We hope to see you again. If you want to make sure that you're not missing any of our webinars, please subscribe to the Next GEOSS webinar series. You simply go to nextgeoss.eu and you can subscribe to the webinar series. eShape we will continue our collaboration with eShape and organize webinars with them. Once we organize together with them, you will be getting a reminder through the subscription to Next GEOSS for sure. But to be sure, follow us on Twitter if you are on social media on Next GEOSS. Next GEOSS is the name, and eShape. If you write eShape in Twitter, you will find the link to the Twitter account of eShape. So please do that, and have a lovely weekend, y'all. Bye-bye for now.
Thanks, Bente, for organizing everything.
Bye-bye. Thanks.